So if I ever come to a point of simplifying fractions that have radicals, you may get to a point like this. And if you're like me and you work on IXL and you type this in, they may not like it. And the reason why is because this is considered not to be in rational form. Whenever we talk about rational form, one rule is that there cannot be square roots in the denominator. We have to have only square roots in the numerator. So we need to somehow figure out to write this in a form so that if there is a square root, it's up in the numerator. Well, how do we do that? And that's where we get the idea of rationalizing the denominator. And so what we're going to do when we rationalize the denominator is we're going to multiply the top and bottom of this fraction by some number that allows me to get rid of, if you will, the square roots that are in the denominator. So what can I multiply it by? And this is where what we're going to do is we're always going to use this number against itself. That's kind of like how I think about it. And so what we're going to do is we're just going to multiply it by the same exact number, the square root of 8. And here's why. It's because what does the square root of 8 times the square root of 8 equal? And to remember that, we need to remember that I have a rule in square root. When I product two square roots together, like the square root of a times the square root of b, what happens is I can write them under one whole square root as the square root of a times b. And now the nice thing about that is when I do that, the square root of 8 times 8 is just the square root of 64, which you may recognize is actually just 8. So when I multiply the square root of 8 times the square root of 8, I get 8. That actually is a very important thing to realize, because if I ever do the square root of x times the square root of x, that just gets me back x. And the reason for that is because the square root of x times x is the square root of x squared. Well, what's the square root of something squared? Well, it's just that thing in the first place. So this is always true, which is nice because this actually turns out to be very little work once we know this. And so if you're familiar with what you have to do to a fraction if you multiply it on the denominator, you also have to multiply it by the same exact thing in the numerator. So now we have 2 times the square root of 8. Since this 2 is not under a square root, I can't combine these in the same way. So what I'm going to do is I'm just going to write this as 2 times the square root of 8. And then 2 times the square root of 8. And now, before I circle my answer, I realize I can simplify this down. The 2 and the 8 combine to get me a 1 and a 4. So this leaves me with the square root of 8 over 4 as my answer. And so that is a rationalized fraction. They have the same value, except this is in full rational form right here. Let's look at one more example. A little bit more difficult, but same process. So let's use this number against itself. Let's multiply it by the square root of 6. If I multiply the denominator by the square root of 6, I also need to multiply the numerator by the square root of 6. Otherwise, I'm changing the number. And I don't want to change the number. I want to leave it the same, just in a different form. And so let's do the denominator first. Remember, square root of some number times the square root of that same number is just equal to that number. So the square root of 6 times the square root of 6 is equal to 6. And then 3 times the square root of 5 times the square root of 6. Well, 3 stays by itself. And then the square root of 5 and the square root of 6, they multiply together under the square root. So that leaves me with 3 times the square root of 30 over 6, which then we can simplify further and say square root of 30 over 2. Again, because 3 and 6 will reduce down to 1 over 2. And just to be sure that 30 doesn't reduce down further, the square root of 30 can be prime factorized into 6 times 5, which can be 2 times 3 times 5. So there's no way that I can simplify this down any further. So this is going to, in fact, be my answer.